Today, we will be teaching you how to solve arithmetic sequences using mathematical induction. We have prepared some few examples for you, and the people will be solving it will be Mark Valmoria and Gabriel Montesclaros.
So we have our arithmetic sequence right here, 20 plus 10 plus 0 plus dot dot dot. So the first thing we have to do is find the summation equation for this arithmetic sequence. So we turn to here. So we first use this. We first end up with this with substitution. A sub 1 plus quantity n minus 1 over d, which is negative 10. So then we distribute negative 10 to here, and we end up with this 20 minus 10n plus 10. Then we get the common factors, and we get every common number. Then we perform the said operation, and we end up with this. A sub n equals 10 minus n over 30. So then we can use this equation for the summation. So we end up with this n quantity 20 minus 10n plus 30, which is a1 plus an. Why am I thinking of? Oh, an, the a1 minus an over 2. Then we have to find the common numbers and perform said operation on them, and we end up with n quantity negative 10n plus 50 over 2. Once we distribute n, we end up with this negative 10n squared plus 50n over 2. You see number 2 here. We can use 2 to lower negative 10n squared and 50n, and we can end up with this once after we factor out n. So we end up with n quantity negative 5n plus 25. So now we can move on to mathematical induction. First part is that we have to prove that 20 plus 10 plus 0 dot 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 negative 10n plus 30 is equal to n quantity negative 5n plus 25. So that means we have to prove that this right here is equal to this, which will prove it true. So if we take the first term, 20, and we equate it to this. We equate to this with n being substituted for number 1, because number 20 is the first term. So 1 quantity negative 5 multiplied by 1 plus 25. And then we perform the operations on the other side. So then we end up with this 20 is equal to negative 5 plus 25. We perform the operation here, and we end up with this. It's 1 multiplied by 20 is equal to 20. And then we end up with this, which means that letter A is proven true. Move on to the second step. We have to assume that n equals k true, which means we have to just substitute n for k. We end up with this 20 plus 10 plus 0 dot 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 negative 10k plus 30 equals k plus negative 5k plus 25. So then we move on. We have to prove that n equals k plus 1 true, which means we have to substitute everything in the equation that has n with k plus 1. So we end up with this 20 plus 10 plus 0 dot 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 negative 10 multiplied by k plus 1 plus 30 equals k plus 1 multiplied by negative 5 quantity k plus 1 plus 25. So then we have to distribute everything, and we end up with this 20 plus 10 plus 0 dot 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 negative 10k plus 30 minus 10 quantity k plus 1 plus 30 equals k plus 1 multiplied by negative 5 quantity k plus 1 plus 25. And then we have, since we see this right here, we'll go back to letter B to look at here. Negative 10k plus 30 equals k multiplied by negative 5k plus 25. So then So that means we can assume that we can substitute this part for this. K negative 5k plus 25 minus 10 k plus 1 plus 30 equals k plus 1 multiplied by negative 5 quantity of k plus 1 plus 25. We have to do everything that's necessary over here, operations, distributions, etc., and do the same here as well, and we end up with this. Negative 5k squared plus 25 plus 10k minus 10 plus 30 equals k plus 1 multiplied by negative 5k minus 5 plus 25. So then, we end up with this, after doing everything necessary. Negative 5k squared plus 25 minus 10k minus 10 plus 30 equals k plus 1 negative 5k plus 20. So then, do everything still necessary, then we end up with this. Negative 5k squared plus 15k plus 20 equals negative 5k squared plus 20k minus 5k plus 20. And then find the common terms and do the operations, and we end up with this. Negative 5k squared plus 15k plus 20 equals negative 5k squared plus 15 plus 20. So then, this statement is equal to each other, which means letter C is proven true.
Given the arithmetic sequence 1 plus 4 plus 7 plus 10 plus 13, we use the equation an equals a1 plus quantity n minus 1d to find the general term. So we get a sub n equals 1 plus quantity n minus 1, 3. We then multiply 3 to n minus 1. So we get a sub n 1 plus 3n minus 3. We combine like terms and we get a sub n 3n minus 2, which is our general term. We then need to find the summation of the arithmetic sequence. So we use the formula s sub n equals n quantity a1 plus an over 2. So s sub n equals n quantity 1 plus 3n minus 2 over 2 becomes s sub n equals n quantity 3n minus 1 over 2. We can then verify n equals 1. 1 equals n quantity 3n minus 1 over 2, which is 1 equals 1 quantity 3 minus 1 over 2, which is then 1 equals 1, which is true. We can then assume n equals k. 1 plus 4 plus 7 plus 3k minus 2 equals k quantity 3k minus 1 over 2. We can then prove n equals k plus 1, which is 1 plus 4 plus 7 plus 3 quantity k plus 1 minus 2 equals k plus 1 quantity 3 quantity k plus 1 minus 1 over 2. It will be then 1 plus 4 plus 7 plus 3k minus 2, because we get the term before. Plus 3 quantity k plus 1 minus 2 equals k plus 1 quantity 3 quantity k plus 1 minus 1 over 2, which is then k quantity 3k minus 1 over 2 plus 3 quantity k plus 1 minus 2 equals k plus 1 quantity 3 quantity k plus 1 minus 1 over 2. It will then become quantity 3k squared minus k over 2 plus 3k plus 1 equals k plus 1 quantity 3k plus 2 over 2. It will become quantity 3k squared minus k over 2 plus quantity 6k plus 2 over 2 equals k plus 1 quantity 3k plus 2 over 2, which we get the final answer of quantity 3k squared plus 5k plus 2 over 2 equals quantity 3k squared plus 5k plus 2 over 2, which is equal, which is correct.